Hello everyone. Today we're going to do exponential functions. But before we do that, we're going to review some basics exponential rules. Okay, so let me go through them. Exponential rules. And some of these rules you have done before. I'll go one by one and I'm going to point out the ones that are very useful. The first one is very basic. You have some number a raised to the n power. And so this means a times a times a n times. An example of one could be 2 to the third. This is just 2 times 2, times 2 3 times, which gives you 8. Okay. The second one is when you have some number and it's raised to a negative exponent. This is actually a fraction. So notice that the exponent now is at the bottom, and now you have 1 over n, 8 to the n power. An example of that could be something as easy as 2 to the negative 3. Notice that the base is positive, the exponent is negative, so this turns into a fraction. And then you do 1/2 3 times, so that's going to give you 1/8. Another one we could do is, what about a fraction? When you have a fraction, this is the same thing as a to the n, b to the n. Number 4, what about if you have a fraction, but this time the exponent is negative? What happens in that case? Actually, this is one of the most useful ones. This actually turns into b over a raised to a positive n. Here's an example of one. Let's say you have 2/3 raised to the negative 2. What does that mean? Well, it means that now you're going to flip the fraction, the reciprocal, 3/2 over, not over, but raised to the power of 2. And then you can apply number 3, and this will be 2 to the second, 3 to the second power, and 2 to the second power. And so that gives you 3 times 3 over 2 times 2, which is 9/4. So notice that 9/4 could be written as 2/3 to the negative 2. So this is something that we're going to be using throughout module 4 and 5, and it's very useful. All right, I'm going to leave this here, and then I'm going to come back to it to show you that this is actually something that we need, okay? All right, let's see, we can do this problem. Okay, so let's talk about how to graph these exponential functions. And what makes it exponential, right? That's something that is new for some of you. Let's do the f of x first. In this example, the base is 1/2 and the exponent is x. So we're going to do a little table. And we're going to select some values of x. Some of them will be negative. We're going to select 0 and positive as well. So -2, -1, 0, 1, and 2. And this is something that you have done before with different functions. This means, for instance, that the domain of this function is going to be all real numbers. There's no restrictions on x. Any x that you can think of works. Now, what about the y value? Well, let's evaluate some of them. Well, this is exactly what I was doing before, where you will have 1/2 raised to the negative 2 power. So what is that equals to? Well, you're going to use number 4. That means you're going to flip over 1/2, and that gives you 2 squared. The exponent now becomes positive. So now 2 squared is 4. And I do the same for 1/2 raised to the negative 1. This is actually 2 for the same reason. Okay, so this is actually 2. What about 1/2 to the 0 power? This is actually 1. This is one of the rules that I should have added at the beginning, and we can call it number 5, is when you have a base that is not 0, some number that is not 0, raised to the 0 power is 1, always, okay? We're not talking about 0 to the 0 power. This is not equals to 1. This is a different story, okay? This is called undetermined. The one that we're referring to is when you have a base that is not 0, raised to the 0 power will always be 1. So in this case, when you have 1/2 raised to the 0 power will give you 1. Okay? And then 1/2 raised to the first power is 1/2. 2 to the 1/2 raised to the second power will be 1/4. I want you to pay attention closely to this. Notice that when x is -2, you get 4. But when x is 2, you get 1/4. So notice that the 4 and the 1/4 are reciprocal of each other. The same thing for the 2 and 1/2, and so on. So this is the table that you must generate when you have these exponential functions. Now the graph of this, I'm going to do my best in this little space. Let's see if we can use a different color here. Let's do it in red. And let me plot these numbers the best that I can. So this is -2, -1, 0, 1, and 2. Okay. This is my domain. The domain is actually all real numbers. I just took a small sample of them. It's impossible to list all the numbers in the domain. It's impossible. We don't do that. Now, let's see if I can plot. Let's start with 0. Let's start with this guy, right? And by the way, that is not the vertex. That 0, 1 is not a vertex. It's just one of the many points on that graph. So when x is 0, the height of the y value is 1. What about when it's -2? Well, when it's -2, you get a 4. So this is 1, 2, 3, 4. So all the way here. When it's -1, the y value is 2. See? So now we have 2 somewhere here. When it's 0, we already did that, it's 1. When it's 1, this time you get 1/2, meaning the y value is somewhere there. And when it's 2, the y value is 1/4. So notice that when I connect these dots, I get this function here. And this is called exponential decay, meaning that the function is decreasing at an exponential form. Decreasing is the key word here. Now, what made it decrease? What is it that I need to look at? And without having a graph, I can tell whether the graph of whatever function I'm doing is going to increase or increase depending on whether it's exponential. Well, what makes it decrease in this case is the fact that the base is 1/2. So we're going to make a general statement and say when the base is between 0 and 1, okay, b for base, then the function, the exponential function, will decrease. Okay, remember that. All right, let's do g of 2. Now this time the base is 2. And I can tell you for general statements that when the base is greater than 1, in this case 2 is greater than 1, the function will increase. Okay, it will increase. So but let's do the table anyway. So we're going to do this little table here as usual. And you know that I'm going to pick -2, -1, 0, 1, and 2. Now, some people have asked me, they say, can I pick different numbers? Yes, you can, but you want to do it in such a way that you have some negative numbers, you have 0, and you have some positive numbers. And don't make it too complicated. You don't want to pick -1/4 and so on. You could, I'm not saying that you cannot, I'm just saying that you should keep it simple, okay? So now I need to evaluate this function when when x is -2. All right, so, well, what is this equals to? Well, this is actually equals, I'm going to use this property now, you see? So what is that equals to? This was going to be equals to 1 over 2 squared, which is equals to 1/4. So here I get 1/4. I'm going to do this a little bit quicker. What is the value of 2 to the negative 1? That's actually 1/2. Again, we come across 2 to the 0, which is 1. And then we have 2 to the 1 is 1, and 2 squared is 4. So this is the table. And notice that I did this on purpose. I have two functions where one of them, the base is 1/2, and the other one is 2. Look at the difference in the table. The x values are the same, but look at the y values are very different. So let me go ahead and graph this here. And by the way, the domain here also is all real numbers. And then once I'm done with graphing it, then we're going to talk about the range. All right, so I'm going to have -2, -1, 0, 1, and 2 again. All right, so when it's -2, I'm going to have that the y value is 1/4 there. When it's -1, I get 1/2. And when it's 0, it's 1 again. Notice that this point is the same as this one. And then when it's 1, I get, sorry, I made a mistake. When it's 1, this is actually 2. You see, I made a mistake, but I corrected it. So this will be 2. And when it's 2, I'm going to erase this here because I need a space. When it's 2, when x is 2, what is the y value? So this is 2, 3, 4, somewhere here. So look, this is what an exponential function looks like. And this is the best, I can do using this computer here. To write on the screen is kind of difficult, but it is what it is. So this is what the graph looks like. Now this time, as I said before, when the base is 2, in this case is greater than 1, then the function will increase. So there's something to know about the graph without having the graph itself. Just by looking at the function, you can tell whether the function is going to increase or decrease. Okay, just like when you were doing the slope. Remember the slopes? When you have a function where the slope is 3, it's positive, you know the line is going to be increasing from left to right. And when the slope is, let's say, -5, then you know that the line is going to be decreasing from left to right. Now, in this case, we do not have lines. We have these graphs, and these are called exponential functions. Now, the one that is increasing is called exponential growth because it's going up. Okay. The f of x is exponential decay. It's going down, right? So if you want to kill a virus, you want to find some medicine that will actually create this effect in such a way that it will die. It will go to 0. It doesn't touch 0, but the tendency is that it will die out. Okay. And the same thing when you have an issue here, when you have money and you want it to grow exponentially, then you make an investment in such a way that it grows exponentially. That's something that is often talked about in finance, but we'll talk about that more in more details later on. So there you have two examples, very basic, and pay attention to the graphs. The base is huge here. You cannot ignore the fact that the base here is 2, and therefore the function is going to increase. In this case, the base is 1/2, which is between 0 and 1, and that will make it go. It will make it go down. It will be decreasing, which is called exponential decay. Now that I have the two graphs, then let's look at the range. Well, the range is going to start from 0, and it's going to go up. So this will be from 0 to infinity. We're not going to include 0 because even though that graph looks like it's going to hit the x-axis, it does not. As x goes to infinity, meaning that you have humongous values of x, the y value gets very, very small, but it does not reach 0. Keep that in mind. The same thing here. The range of g of x will be from 0 to infinity for the same reason. It doesn't touch the x-axis whatsoever. In fact, The x-axis in these two examples is called an horizontal asymptote. Okay, this is a topic that we did in module 3, horizontal and vertical asymptotes. Okay, all right, let's move on to another example. Now look at this here. Now I have kind of a similar situation. The only difference is that now I have a negative in front of the parentheses. Something that I want to mention very quickly is that sometimes you might see this, and I have to be honest with you that I don't like it when I see this. I don't like this because I prefer to use a bracket, parentheses on the base, so that the negative is outside the parentheses and not in the base, okay? And so what do you think this negative outside the base does, outside the parentheses? Well, you already have the graph of this one. You see, you already have it. So what's going to happen then is that it's going to flip it around. So let me do this one here in blue. So if I were to put a negative and do this graph, what does it do? Well, it's going to do this. It's going to reflect this graph. It's going to flip it over across the x-axis. And so therefore, you're going to have something like this. That's what the graph of that looks like. Okay. But that's the effect of the negative outside the parentheses. So when you do this one here, let's do it. Why not? Let's do the table. Okay. So we have to be very careful with the negative. Okay, so let's pick some negative numbers, -2, -1, 0, 1, and 2. Now I have to be very careful how I do this. So I'm going to evaluate this function with -2. I'm going to show you step by step. -2. Okay. -2. The exponent there is going to be -2. So what do I do with this? We have to be very careful. Remember, let's take care of the exponent first. 1/2 raised to the -2 is actually 2 over 1 raised to the +2, and that is equals to 4. Now you take care of the negative, and so therefore you end up with -4. You see? And you continue that process. F of -1 would be -1/2 to the -1. So what does that mean? It means that this 1/2 to the -1 is actually 2. And then when you put the negative in front of it, it becomes -2. Now, this is a tricky one. What happens when you have f of 0? Well, you have negative, then you have the base 1/2, 0. Well, I told you before that any non-zero number raised to the 0 power is 1. It's just that it will carry over the negative. So it will be -1. All right, so this will be, when it's 1, it actually will be -1/2 and -1/4, just to do this quickly, okay? And let's see what the graph looks like. Let's change colors. Let's do it in red. So let's do this one first. Again, that's not called a vertex. That would be 0, -1 there. I'm going to put -1, -2, -1, 0, 1, and 2. When it's -2, what do I end up with? -4. This is -1, -2, -3, -4. So I end up somewhere here. When it's -1, I end up with -2. When it's 0, I end up with -1, which is this one. When it's 1, I end up with -1/2. When it's 2, I end up with -1/4. And so there's your graph, you see? And there you have it. This is going to take practice, but it's doable. This is not something that is out of reach. You know already how to evaluate a function. It's just that this is a new function that we call exponentials, okay? All right, let's do this one. This one is interesting. Look at that. The one that we did before, this one, it was 2 to the x, right? 2 to the x, and we did it. But this guy, guys, is 2 to the negative x. So let's clean that up. Let's see if we can, what do we do with that, right? So let's do this. I'm gonna do some basic algebra here. Would you agree that this is the same? You see? I can multiply -1 times this x, and I will get back 2 to the negative x, okay? That's perfectly legal. Now, inside the parentheses, I have 2 to the -1. Well, 2 to the -1 is actually 1/2 to the x. So basically, guys, this is nothing more than 1/2 to the negative, 1/2 to the x. And that graph, my friends, we have done it already. That's one of the first one we did. You can look back in the video and you can see that this is the graph of it. Okay, I did that so you can see what is the effect and how do you handle cases in where the exponent, in this case negative x, is actually negative, right? You have this negative sign in front of the x, and what do you do with it? Here, well, I just show you what to do with it, and notice that you end up with something that is very familiar. Okay, all right, let's do another one. Look at that one. Look at that one. Okay. All right. Now we have negative in front of the parentheses, and we also have a negative x. Let's take care of the negative x first. So we're going to write 1/3 to the negative x. Well, this is actually going to be 3/1 to the x. Now, you don't have to write 3/1, right? You just write 3 to the x. But I wrote it to show you that's where it goes, right? You take the reciprocal of 1/3 and you get 3/1. Now, so what does that mean? It means then that what I need to graph is this. And that is easy to do, right? We can do that very easily. Let's do a table. Let's do -2, -1, 0, 1, 2. All right, let's do here. Let's do someone in here. F of -2. What is that equals to? Well, here we go. What about, let's do this on the side. 3 to the -2. What is that equals to? That is equals to 1/3 squared, which is 1/9. Now, when you put the 1/9 in front of the negative, it becomes -1/9. And the process continues. So you get -1/9. Then the other one would be -1/3. The other would be -1. When x is 1, I'm going to end up with, let's see, what do you end up with? Where is it? Oh, there it is. Sorry, I lost track of time where I was before. So you're going to end up with -3. And finally, I'll do the last one so you can see what I'm doing here. When f of 2, remember, I'm evaluating this one now because those two are the same. This guy is the same as this one, okay? So f of 2, so that will be -3 squared. Well, that would be negative. What is 3 squared? 9. When you put the negative in front of it, it becomes -9. There it is. And then you do your best to graph this thing, right? No big deal. Let's do this one first. Okay. 0, -1. What about when it's 1? Let's do this one. 1, and then 2. When it's 1, you get -3. Ooh, -3. So this is -1, -2, -3. You get a number here. When is 2, you end up all the way down. I cannot even graph it because it's all the way down to -9. It's out of my screen, okay? But get the idea that it's somewhere there. And what about these other numbers? When it's -1, let's say -1 is here, the y value is -1/3 there, okay? And when it's -2, you get even smaller, -1/9. And so your graph, and by the way, at this point, I don't mind, guys, if you use a graphing calculator, because it will help you with, understanding what the graph is and get an idea of the actual graph. So this is the actual graph. See, that is the actual graph. Okay. All right. So now remember that graphing is good, but you still have to do the table. That's why doing the table and actually generating the order pairs is key. And by the way, before I forget, remember that you know what to do in Alex to enter 1/9 and 1/3 and so on. You have the little box to enter it. Don't forget that feature. Okay. All right. So that is what we're doing in module 4. This is the beginning, and I hope this helps. And one thing that you should review is this. By the way, I almost forgot this one. Now, we're going to translate this, right? We're going to move it around. Now, if the graph that you had was only 2 to the x, you know what the graph is, right? We did it. Let's say it's this one. This is 2 to the x. Well, what about 2 raised to the x minus 1? What does that mean? That means that I'm going to move this point 1 unit to the right. There it is. Then I'm going to move this point 1 up, 1 unit up. So now I have a shift. And that will be my shift. I shifted 1 unit to the right and 1 unit up, just like you have done before on module 2. Remember when you started shifting graphs and you were learning basically the shapes of parabolas, square root properties, and so on, square root functions, so on, cubing functions. The way that you shifted those applies to this, is in general. So moving this around is not going to be an issue. The only thing you have to learn here is the different shapes of them and the effect of this negative, to work them out. But here's a video. You can watch it as many times as you want, and I'll be glad to answer any questions in class. Okay. All right, guys, I'm going to stop here for now, and I'll see you soon.